said, we're going until 11:30, and I will see that we're ending right on time. I know it's a big schedule for nationals, and you don't want to be blending into other issues. So this half is about developing a healthy breed program. It's about the health issues in your breed, as well as how to breed away towards the things you're selecting for and away from the things that you want to select against. So when we talk about breeding goals, the number one breeding goal must always be to maintain and enhance the quality of the breed. And a lot of people are surprised that I say that. They say, well, shouldn't the breeding goal be, to produce healthy animals? And yes, that is extremely important. But the bottom line is there are a lot of healthy mixed breed dogs out there as well. Okay, so you're breeding Great Pyrenees. And so really your breeding goal is to produce the best Great Pyrenees in both quality and in health. And that's what's the important aspect of it. Because if we want to just breed for health, then in reality what the molecular geneticists are telling us is that crossbreeding is the healthiest breeding we can do, because then you'll never double up on deleterious recessives that are very low frequency outside of the Great Pyrenees breed. And in the Embark seminars, they even said that, the healthiest breeding would be just to break the constraints of your AKC pedigrees and breed for other dogs that look like your breed, and you'll get really healthy dogs. You get a lot more variability in your breed, but that's, if healthy dogs is all you're looking for, that's the way to go. But that's not what we're looking to do. We're looking to be breeding quality Great Pyrenees. So we don't want to limit the genetic diversity of the population and diminish our choices and our ability to make selection goals with our dogs. So genetic disease control is equally important underneath the banner of breeding quality Great Pyrenees, and our number one goal is to not produce affected individuals in the next litter. And sometimes we have complete control over that if we have single testable gene disorders, as you have. Other times we don't have complete control. We can try to select against osteosarcoma, which is definitely inherited. We can try to select against hip dysplasia, but sometimes those things will still pop out. But at least we're doing the best that we can, and we're diminishing the risk or the frequency of producing those disorders if we are actively selecting against them. And the other thing we need to do, though, is we need to decrease the frequency of carriers of defective genes in the population. And this is something that some breeds have not embraced. They have testable genes, and there are some breeds that say, only test your studs and don't test the females. And as long as your studs are normal, it doesn't matter if they're being bred to carriers, they'll never produce affecteds. And that is true. But if you're looking at the entire population, if we're breeding carrier to normal matings, you're producing 50% carriers in the offspring, all right? And most defective genes are not at 50% in the population, so actually increasing the frequency of those defective genes. And then if you have multiple genetic tests like you do for your breed, if you're a carrier for one thing, then I can only breed to a normal for that gene. And that eliminates anyone that's carriers for that gene. But also, I've got another testable gene, and I'm not a carrier, and if I'm a carrier for that, then I can't breed to anyone but normals for that gene too. And all of a sudden, we're limiting who we can breed to, not based on being able to produce the best quality Great Pyrenees, but to not produce the different diseases. So this is why it's important to decrease the frequency of carriers, because it increases our choices to actually breed for what we want to be breeding for, instead of continually backtracking to not produce those testable genetic diseases that we should be able to easily control. Okay, so let's talk about genetic screening and genetic testing. I think these two guys know each other. I don't think this was just a chance encounter. I think they enjoy their relationship. Okay. So here's your next polling question. What genetic screening do you do in your dogs? So again, genetic screening is not just DNA testing. It's any kind of screening for disease. What screening do you do? Hips, hearts, and eyes. CMR, DM, and NDG, so you've got your genetic tests. We'll talk about the relevancy of those tests. Still typing, so hold on. Hips, patellas, heart, CMR1, NDG, dwarfism, okay. So you got your phenotypic tests, and then you've got 3 DNA tests there. Okay, hips, hearts, eyes, all 5 genetic tests, elbows and patellas, hips, patellas, elbow, hips, patella, CMR, GT, DM, NDG, dwarfism, elbows, lifespan. Definitely lifespan is important for long-lived dogs. You know, there's not a gene for lifespan, but you're selecting against those diseases that would shorten their lifespan. So you're selecting against cancers that would shorten their lifespan. You're selecting against other debilitating diseases that can shorten the lifespan. Okay. All right. So there are several types of tests that we can use to screen. There are tests of the genotype, which are direct tests of the DNA to test for liability genes. There are tests of the phenotype, which are to particularly identify affected dogs. Most of the tests for the phenotype won't identify carriers, so that's hip radiographs and elbows and patellas and hearts and eyes and so forth. And then there's pedigree analysis, which is the identification of carrier risk based on the knowledge of carrier and affected relatives in the pedigree. So you need an open health registry that lists test results like the OFA has, and you need to be able to have that information to utilize. So there is genetic panel screening by Embark and Mars. This has become the standard of the general tests that they want to sell you. It tests for now it's over 200 genetic diseases actually, more than 20 traits including coat color, coat type, morphology, size, and so forth. They can tell from the genetics what these things would be. There's the genetic diversity or homozygosity testing that we spoke about, and usually cheek swab tests. And one thing we need to understand is it uses what are called SNPs, or single nucleotide polymorphisms. So a nucleotide is an A, T, C, or G, which is on the chromosomes, the 4 letters that make up the DNA. And so these are looking for single nucleotides. And if you have mutations causing disease that are longer than 1 nucleotide, these tests don't actually test for the mutation. It only tests for a letter within that mutation, and they're saying that if that letter's there, that mutation's probably there as well. But it also possibly might not. So these are not direct tests for mutations unless the mutation itself is just a single nucleotide substitution that causes the disease, in which case this is a direct genetic test. And so we need to understand if we're making breeding decisions based on genetic test results, it should be based on mutation-based tests and not SNPs. Although, as I said, if the mutation is just a single nucleotide change, then these panel tests are giving you accurate results in that regard. So it really depends on the disease itself. The International Partnership for Dogs, or IPFD, they have a website called the Harmonization of Genetic Testing for Dogs. It lists all of the genetic tests that are available for DNA testing. It lists what labs run those tests around the world. And they also have breed relevancy ratings, which tells you, even though you can test for a gene in a breed, does that disease actually occur in the breed? Is that a relevant genetic test in the breed, or is it something that you're wasting your time with, and maybe even detrimentally affecting your ability to select by using those tests? So you can just, you can Google DogWellNet or Harmonization of Genetic Testing or dogwellnet.com/CTP in the website, and it's in your handout as well. So the breed health survey that you have, I was given the raw data from that survey and I analyzed that. And essentially what it contains is dogs starting from 2007 on where people have filled out their health surveys. And my understanding is that these are both club members as well as non-club members that filled out the survey. I'm not aware of how it was conducted or anything else like that, but I was looking at the data. There were 650 Great Pyrenees dogs that were included in the survey results. And for testing, it said that 41.8% of the dogs had their hips checked, either OFA or pen hip in that regard. 17.7 had their patellas checked. And those are the two requirements for CHIC certification. We'll talk about CHIC a little bit later. Then we had 13.2% on patellas, 13.2% cardiac, 12.9% elbows, 12% eyes, 3.8 thyroid, 2.5 shoulders, and 1.5 hearing or bear testing. So this is just based on those 650 dogs and the health tests that the owners listed that were done on their dogs. All of these other tests are on the elective. So your CHIC requirement is hips, patellas, and then one of many different electives which include all of these things. And the electives are indicating to us that these diseases do occur in the breed, but they're not as high frequency as hips and patella disease are in that regard. Hearing being lower frequency, you've got OCD in the shoulders and so forth. And we'll go through a lot of these diseases as we move along. The cause of death in the dogs here. Based on the health survey, there were over 200 dogs, or actually there were exactly 200 dogs that had a cause of death listed. And so the number one cause of death listed in the health survey was osteosarcoma at over 17%. So that certainly is a high frequency disease causing death in your dogs. Other non-specified cancers at 13%, old age at 12%. And again, there is no such thing as genes for old age or longevity. It's what diseases kill dogs at what age, and it's selecting against those individual things. But when we consider old age, we're pretty much for a Great Pyrenees, we're considering issues with walking, standing, hind end, arthritis and so forth like that. So this is, trouble walking, standing at over 10%, and 12% old age are probably looking at similar conditions there. Heart failure at a little over 7%. And then you've got listed here degenerative myelopathy at almost 5% as a cause of death. And I have to tell you that, and we'll go over all of this here, degenerative myelopathy as a very specific genetic disease. It's a specific genetic disease with a very specific diagnosis and cause, genetic cause. That does not occur in your breed. Okay, and I'll show you all of the data, and I'll go over that data with you as we talk about it. But you do have a lot of disease that causes weakness in the hind. You do have some neurological spinal cord diseases. You do have myelopathies. Okay, but they're not degenerative myelopathy, a very specific disease diagnosis that only occurs really in 2 breeds plus a handful of other breeds, and does not really exist as a breed-related disease process in other breeds like the Great Pyrenees. You have the people that did this survey way back when, they had some designations, degenerative spinal myelopathy. That's probably a more appropriate term for any neurological disease of the spinal cord that you're seeing in your breed, but not specifically DM. You've got DJM is degenerative juvenile myelopathy, which is probably neuronal degeneration, but before they even had a term for it, back when people were starting to diagnose these things going back to 2007. So that's a young age myelopathy that deteriorates the spinal cord and the nervous system. So then you've got bloat and torsion. You've got hemangiosarcoma as your number one malignancy in your breed. And the percentages here, maybe they're accurate, maybe they're not, but the relative frequency of these diseases is definitely significant. So osteosarcoma is definitely the number one cause of death of your breed for a specific disease process. And each of these decrease in frequency, aggression, bad enough to cause euthanasia, arthritis, mammary cancer, brain tumor, liver failure, stroke, traumatic injury, kidney failure, bladder cancer, liver cancer, renal dysplasia, and Addison's disease. So I will talk about the majority of those. Addison's disease does occur as a genetic disease in your breed at a low frequency. There are no genetic tests for it. It is complexly inherited. A lot of it's being worked on at UC Davis. Excellent genetics department there, and it's also being looked at in Europe as well in many different breeds. So that's your cause of death based on the health survey. The AKC Canine Health Foundation asks every breed club every couple of years to list the most important health concerns for your breeds. And then they compile all of that data because they are funding millions of dollars every year in health research, and they want to make sure that they're funding research that benefits the most number of breeds across all of dogdom. So that's important to them, even though they will fund breed-specific disease if you bring that to them and say, we need degenerative, neuronal degeneration research, and it only occurs in our breed, and we can find funding for it, and we will match the funding. They will do that research. But in general, they want to do research on cancer, and research on hip dysplasia, and research on epilepsy and PRA that affects many, many different breeds. So, next poll question. What genetic disorders are you seeing in your dogs? What specific genetic diagnoses are you seeing in your dogs? And again, this is an anonymous survey. Okay, canine multifocal retinopathy. We'll talk about that. Osteosarcoma, dwarfism, CMR, degenerate myelopathy, neuronal degeneration, allergies, I was surprised to not see as much allergies in your dogs as I do when I analyze other breeds and other dogs, and especially being a white breed. White dogs tend to have more allergies in general. As a veterinarian, we all know that. And many white breeds have much more problems with allergies, but your breed does not. And your breed really will look at the numbers very quickly, but you don't have as much an issue with hip dysplasia and elbow dysplasia, and you expect a giant breed to have those issues. So you're doing really well in those regards. Seizures, epilepsies, okay. Arthritis. All right, okay, so let's look at specific disorders here. So the Canine Health Foundation, they list the top 20 diseases. Hip dysplasia is the most concerning across all breeds. Epilepsy, allergies. Now, PRA used to be number one, and PRA is on the second part of the list now because we found and identified so many of the PRA genes, it's no longer a problem of having all these deaf, blind dogs anymore. Allergies, hemangiosarcoma as the number one malignancy cancer, hypothyroidism, lymphoma is the number 2 malignancy, bloat has moved up on the list, patella luxation, cruciate ligament rupture, inflammatory bowel disease. So how many of these things do you guys have issues with? Hip dysplasia, a little bit of these, hemangio, hypothyroidism, a little bit of lymphoma, bloat, patella luxation, a little bit of ACL. I'm not sure about IBD, but certainly you guys have the things that are high on the list there. The second 20, cataracts, osteosarcoma, atopic dermatitis or allergic inhalant allergies, elbow dysplasia, immune-mediated hemolytic anemia, where the body destroys its own red blood cells, an autoimmune disease, cardiomyopathy, PRA, breast tumors, retained testicles, mitral valve disease. So those are the top 20 across all breeds, and certainly you have a lot of things that are on that list there, because these are shared across all dogs and probably have some common genetics between breeds as well. Okay, so here, going back to your health survey of over 650 dogs, cancer was your number one issue at 14.6, just in general, a listing of cancer without specifying which type of cancer. Allergies, 7.2, that's kind of common to see allergy high in the list across all breeds. And again, our relative numbers here may or may not be accurate, but the relationship of the higher versus the lower are going to be accurate in terms of which is more common than others. Osteosarcoma being a very frequent disease and cause of death in your breed. Hypothyroidism, 5.7%, we'll talk about that. Ear infection is actually a relationship to allergies. Chronic ear infections are all due to allergic reactivity. Hip dysplasia, patella luxation, breast tumors, arthritis, ACL, cruciate ligament tear, subaortic stenosis or heart disease, a specific type of heart disease, renal dysplasia, hemangiosarcoma, Addison's disease, there's your CMR, cataracts, and bloat. So those are the most frequent diagnoses based on that combined health survey. It is heavy in the earlier years on the survey. There aren't a lot of, I'm not sure how functional or how your health survey is working right now, and I'll give you some recommendations as to what I think you should do for a health survey, but there were not a lot of dogs listed or added within the last year or so on that health survey from the data that I received. Okay, so let's talk about specific diseases, and we'll look at different registries that give us that information as well. So OFA runs the Eye Certification Registry, or ECR. This is what replaced CERF. The ophthalmologists came to the OFA and said, we would like you to take over the certification that we do with the eye checks. The OFA is able to provide a lot more data to them as well, and CERF as an organization was not able to fulfill all the requests that the ophthalmologists were looking for. So we've taken that over, and so this is for between 2016 and 2020, 141 dogs were examined. Actually, this is 141 examinations, so some dogs may be in there more than once, but not a lot of them. And so 57.4% of peers had normal eyes, completely passing normal. 25.5% have persistent pupillary membranes, which is a fetal membrane that should completely degenerate, and you're left with a couple of strands connecting the iris to iris. These are considered non-pathologic. It doesn't cause disease. It doesn't cause any problems. We see this across all dogs. It's incidental, and we don't select against it, so it's not a problem. If you have a PPM that goes from the iris to the lens, or iris to the cornea, or a whole sheet of a persistent membrane that did not degenerate, those can cause vision problems and should be selected against. Cataracts, significant, 11.3%. It isn't broken down by age of cataracts, so that is, it doesn't tell you whether you have juvenile cataracts versus senile or age-related cataracts, but I suspect that this is mostly senile cataracts or age-related cataracts in your breed. Incipient cataracts, or cataracts that are just very, very small, that have not developed. Here's your CMR, 5.7%, based on ophthalmologic examination. So this is a number that you can quickly bring down through selection, and we'll talk about that though, because CMR does not cause blindness. It causes some vision issues, but not issues that are usually readily observable in the dogs. They have portions of the retina that degenerate, and in people it causes blind spots, but you can still look around and see everything, and your dogs are probably not complaining about it, but it is still something we should select against, and we do have a genetic test for. Uveal cysts don't cause a lot of issues. In some breeds that have pigmentary keratitis or ocular melanosis, such as Cairns and Golden Retrievers, these cysts become important because that is a precursor of those conditions. You don't have those conditions in your breed, so I'm not so sure that we need to select against them right now. Cataract significance unknown. I hate this category. I think it's a category that ophthalmologists check off if they don't want to piss you off and say, well, it's got a cataract, but who knows the significance? Shrugs his shoulders. Well, who should know the significance, Mr. or Mrs. Ophthalmologist? It's got a cataract. At least the ACVO says any Great Pyrenees with a cataract should not be bred. Okay, so they're not differentiating significant from significance unknown, but unfortunately there is a checkoff for that. An incomplete cataract, corneal dystrophy, which does occur at a low level across all breeds, doesn't normally affect vision, and then iris lens PPMs. So again, the ophthalmologists say don't breed dogs with a cataract, and I think that's a good recommendation. In terms of breeding dogs with CMR, you want to know who you're breeding to and what their genetic test result is, because you have an excellent genetic test for that. Okay, hypothyroidism in the Great Pyrenees. We need to understand that this is a diagnosis of autoimmune thyroiditis. That's what genetic hypothyroidism is in a dog in Great Pyrenees. It's not just thyroid responsive conditions. It's not a dog whose hair coat is a little poorer and you supplement with thyroid and their hair coat gets better, because that's going to happen. It's not a dog that's obese and you get them on low thyroid and it slims them down a little bit. That doesn't mean they had hypothyroidism. Some reproductive specialists, if a bitch keeps missing heats and they run a thyroid profile and it's below the average for the breed, they'll supplement thyroid, and sometimes those bitches will get pregnant. But that doesn't mean they had autoimmune thyroiditis. This is a very specific disease, and it's by measuring the autoantibodies in the bloodstream. 6.5% of almost 1,000 Great Pyrenees tested by Michigan State University, which is the gold standard for testing, are positive for thyroglobulin autoantibodies. The average for all breeds is 7.5. So yes, you've got autoimmune thyroiditis, but not much more than the average across all other breeds. So it's not like English setters or some breeds that have extremely high frequencies of this disease as a high frequency disorder. And 3.6% test equivocal, which means questionable answers, because it's a phenotypic test. You're looking at hormone levels that change from day to day, and sometimes you might have a little autoantibody, you might have a low thyroid, but you don't have a high TSH. So in the profile, you get some numbers that don't coincide with the picture-perfect diagnosis, and those are called equivocal. So it's an average amount of hypothyroidism in the breed. On your OFA thyroid, for those that have submitted your thyroid profiles to OFA, 188 dogs, 90% normal, and here you've kind of reversed it. You've got 3.2% affected and 6.4% equivocal, almost the opposite of what you were looking at before, but you're still looking at about 10% that may have a thyroid issue going on and that you should screen for in that regard. So there are no other genetic tests for hypothyroidism, so this is something you need to screen for. And we need to understand that a thyroid profile is a snapshot of a continuous disease process. It's a range from 2 to 6 years, with peak levels at 4 years of age where those autoantibodies are occurring. So the body produces antibodies against its own thyroid gland. It slowly destroys that thyroid gland and replaces it with fibrous tissue. Once that thyroid gland is destroyed, the stimulus for the antibodies is gone, so those antibody levels go down again. You can no longer measure the antibody levels. You're left with end-stage hypothyroidism. So in order to diagnose it, you need to catch those antibody levels at that temporal period. And what I recommend is 2 thyroid profiles on breeding dogs, 2 years apart, anytime between 2 and 6 years of age. And if both of those are negative for autoantibodies, then your dog is not affected with autoimmune thyroiditis. Doesn't mean they don't carry genes for it. You still need to look at the family to determine disease risk, and we'll talk about that at the end of the talk today. Hip dysplasia. Okay, you ranked 121 out of 191 dogs based on 6,760 rating graphs on Great Pyrenees dogs. So this is where you don't want to be number one. Okay, I want to be my breed one needs to be number one. Well, not this time. Okay, you want to be low on the list, and you are quite low on the list there at 121. You know, well below the average across all breeds, and certainly for a giant-sized breed, that is a low number. 90.4% are normal, 15.1% are excellent, and average for all breeds, including your little breeds, is 15.7. So that's a good number. You've got 62.6% OFA goods. You've got 12% OFA fairs, 8.8% dysplastic, and the average across all breeds is 11.4. So that's pretty darn good. This is looking at all Great Pyrenees back to the inception of the OFA database. So it's really averaging out what's happened over the total evolution of your breed since the 1960s. But you've got 5.1% mildly dysplastic, 3.3% moderately, and 0.4% severely dysplastic. And that's the type of trend that you would see, because it's the outline of the end of that bell curve in terms of the disease. You see the most severe, least, and then a little bit more, and a little bit more for the mildly dysplastic. So that's pretty good for your breed. In terms of trends, you know, we look at 5-year periods here and how many dogs are submitted. Your percentage of excellence have continually gone up over the years, and that's a big benchmark for OFA, saying that your breed is working towards more of an excellent phenotype. Your dysplastic phenotypes, they went down for a little bit, up a little bit, down a little bit, up a little bit again. Here we only have 3 years because we don't have a full 5-year. So these are dogs born in these years, not the years of testing. And since we don't test until they're 2 years of age, at the end of this year, we'll finish 2019, dogs that were born in 2019, and be able to add them to the list. So you've got a little less dogs here, but that's what we're looking at. So you're doing pretty good with hip dysplasia. Don't take your eye off the ball and not pay attention to it, but certainly continue to work towards better hips. Patellas, okay, so with the patella registry, you got to consider how the different registries work, because even the hip registry probably underreports hip dysplasia, because if your vet takes an x-ray and says, this dog is obviously dysplastic, you want to send it in, and you say, I'm not spending the money to send it in, I already know it's dysplastic. So it underreports a little bit in that regard. For patella and for hearts, it over-reports normalcy, because you already know whether it's affected or not, and the question is, am I going to send this in? So actually for patellas and hearts, if you send in an affected, it doesn't cost you anything. You don't have to pay the $15 or the $7.50 if you're getting a kennel group, to send those reports in if they're affected. You can send them in for free and they'll go into the open database. But most people don't do that, so you're only seeing 1% affected on patellas, and we certainly know that patella luxation occurs more frequently than that in your breed. There is no genetic test for it, and you need to use selection against the complexly inherited disease for hips, for patellas, for osteosarcoma. These are all complexly inherited diseases, and we'll talk about that. Elbow dysplasia, again, you would expect on a giant breed to have a lot of it. Bernese Mountain Dogs are number one. Rottweilers are also 1 or 2 for elbow dysplasia, and you guys have managed to, once again, you're 110 out of 135. Now this is where you go, yay, we want to be 135. You don't want to be number 1. 1,342 evaluations, 98.2% normal, 1.7% have elbow dysplasia. The vast majority grade 1s, and then a couple of grade 2s, 6 dogs, no dogs with severe grade 3 elbow dysplasia. The thing with elbow dysplasia you need to understand is that grade 1s rarely have arthritis, during your lifetime from this condition, but you can diagnose it on the x-ray. So it's not a clinical disease for grade 1, but what you'll find is if you see a grade 2 or a grade 3, and you go ahead and x-ray close relatives to that dog, you'll see a lot of grade 1s. So grade 1s is telling you that you are collecting elbow dysplasia liability genes, and you need to watch out or you're going to start producing clinical elbow dysplasia in that regard. And that's why you need to pay attention to grade 1s and select against them when they do occur. Okay, chondrodysplasia or dwarfism in Great Pyrenees, and there was just one walking around here a few minutes ago. This is one of your old pictures. Here's one of your more modern pictures from the University of Minnesota websites on dwarfism in Great Pyrenees. It's a simple autosomal recessive disease. So when I spoke, how many people here were here 20 years ago in 2001 when I gave this lecture in Eureka, Missouri, outside St. Louis for your breed health seminar? A couple of you, okay, all right. So at that time we said, we're pretty sure it's an autosomal recessive, there's no genetic tests, you know, and so a lot of the things we now have the answers to those things. So it's nice 20 years later to be able to say we have progress here. They're born normal size, but they grow much more slowly. By 14 weeks of age, it's evident. If you're used to seeing them, maybe you can pick it up even earlier than that. They can also have hearing issues. They can have dental issues because there's a lot of crowding of the teeth as well. There is a genetic test available from the University of Minnesota Canine Genetics Lab. It is the only laboratory that can run this test because they identified the gene. They have not published it yet. And the reason they haven't published it is because once they publish it, they lose the ability to run the testing and to continue to research your breed and help your breed out. And this is what happened to them with EIC and Labrador Retrievers, exercise-induced collapse. They developed the test, they were the sole person, sole lab running the test, and then they tried to patent the test, and other labs started running it. They tried to sue to say, we have a patent on it, and the courts threw out the patent and said you can't patent a natural mutation, and so they lost the income from that. So it's a political thing about, you run a laboratory by running tests because grants don't come along as often as genetic testing, and so this helps them do more research for your breed, and that's why they're doing it. The fact that it's not published, I know these people, I've seen the research. This is absolutely a correct test, as is the one for Neurology Generation. So trust your test results from University of Minnesota and submit samples for testing. It's giving you accurate results. But that's why it has not been published, because they lose the ability to monitor this and do more research for your breed. This dwarfism gene is not related to the other testable chondrodysplasia genes that are seen in other breeds that are much more common mutations. So don't get fooled into testing for the chondrodysplasia gene at UC Davis or at Vetchen or the chondrodysplasia genes that are tested by Embark or by Mars. Your breed-specific gene is not being tested by any of those companies, and you need to not look at those for test results to inform you about your dogs. It's only the University of Minnesota laboratory at this time that's running that test. They have tested 508 dogs, 86.8% test normal, almost a 10% carrier rate at 49 dogs, and 3.5% affected, 18 dogs. This is, even though you've got over 500 dogs here, this is a skewed population. It includes the research population that originally was submitted to them that was litter after litter after litter of affected dogs of carrier-to-carrier matings. And so this carrier frequency is probably higher than what exists out there in the real world. But it occurs frequently enough. It's an easy test to do. You should all be testing for this in your breeding dogs so you don't produce dwarfs. So not that they aren't cute, but they're not Great Pyrenees that are the quality that you want to be producing. I mean, in Gordon setters, we get red setters. You get dogs that aren't black and tan. They're tan, and then a little darker tan because the black, we have the red gene. And not that these aren't healthy, wonderful Gordon setters, but a Gordon setter is black and tan. And so you want to breed black and tans. And your dwarves are going to have arthritis and other things later on as well. So it's not something we want to propagate as another type of Great Pyrenees. We want to select against it. So Neurology Generation is the other gene that was discovered at the University of Minnesota solely because they already had the DNA from the Dwarfism project that they were able to quickly find this gene as well for you. Onset under a year of age. It's not a painful condition. It's a neuronal degeneration, so it does not cause pain. Initial signs, slipping, sliding, difficulty maneuvering on smooth surface, weak, clumsy, uncoordinated, eventually wide-based stance, unable to negotiate stairs, intermittent falling. It's an autosomal recessive mode of inheritance, simple recessive, and the genetic test available from the University of Minnesota. So they have developed this test for you as well. They can run both tests for you on a single DNA sample. If you've already sent in a sample for dwarfism, they still have your sample, and all you do is contact them and say, I want a Neurology Generation test run on the DNA that you already have, and they can do that for you. And then you have the results of both of those tests. So both simple autosomal recessive, completely penetrant. If you've got the gene in a homozygous in a gene pair, the dog will be affected. There are some genetic diseases where that does not occur, where you have what's called incomplete penetrance. That doesn't occur with these diseases. This is something you need to test for and not produce homozygous affected individuals. Okay, 650 dogs have been tested at University of Minnesota, 87.1% normal, 11.8% carrier, 105 dogs of the 650, 9 infected dogs. So again, this number is probably higher than what it actually is if you're testing the entire Great Pyrenees population, but this includes the research litters that were included to identify this gene as well. So as more testing goes on, you're going to come to a number that's more likely accurate for your breed in terms of the frequency of this gene. But an easily testable gene and a disease that you can easily get rid of. And we'll talk about how you deal with autosomal recessive diseases, because it doesn't mean throw out all your carriers, because you don't want to lose the quality of your breed that way if you have a genetic test. So we'll talk about that in the end. Okay, platelet dysfunction in Great Pyrenees, Landsman's thrombocythemia, that was originally identified by Dr. Boudreau in Auburn. A bleeding disorder, especially when young, excessive bleeding during teething. They can have frequent nosebleeds, but it's not like hemophilia where these dogs are going to bleed out. You know, it is a nuisance type of thing. Their platelet numbers are normal. It's an abnormality in platelet function. Simple autosomal recessive mode of inheritance. You've had a genetic test now for well over 20 years, because I talked about the genetic test 20 years ago. And it's available from many genetic testing companies and laboratories. So almost all genetic testing labs can identify this gene for you. So OFA has 50 dogs that you've registered the test results on, 100% normal, none are at risk. Paw print genetics have 99.3% normal, 0.7% carrier, 0% affected. Those should say affected, because actually homozygotes are all affected, not at risk. Mars genoscoper testing, so wisdom panel testing, 98.9% normal, 1.1% carrier, and MBARC testing, over 1,500 Great Pyrenees tested, 100% normal. So you guys have tested this for over 20 years, and this used to be a much higher frequency disease in your breed, and now it's almost non-existent as a clinical disease and almost non-existent in a carrier state as well. So you want to utilize parent-tested normals. So if 2 parents are tested that are normal, you don't have to test the offspring, because you know they're genetically going to be normal. But then if any of those are going to be used for breeding in the future, they should be tested again once they're bred to another individual in that regard. So don't take your eye off the ball, but you have almost eliminated this disease as a breed-related disease. Familial juvenile renal disease or renal dysplasia. And the only reason I'm bringing it up is because it does occur at a very low frequency in your breed. It usually presents initially with increased drinking and peeing. And it's a dilute urine, so their bladders fill up quickly, so they can't avoid having accents because they have to pee. And in young dogs. And there's variability in the severity of this. There are dogs that live to ripe old age with renal dysplasia and you know, don't die because of that, but their kidneys are impaired throughout their lives. They're always drinking and peeing excessively, and it is a genetic disease. They have elevated BUN and creatinine or the kidney values. It can be severe, where they actually die as a young dog from renal failure, or it can be a mild lifelong. There's a complex mode of inheritance of this disease. I was involved in the original research with Dr. Mary Whiteley and dog genes on her paper on COX-2 variants as a genetic test for renal dysplasia. And I was very adamant about how the paper was written because we did not prove that that gene causes renal dysplasia. All it showed was a correlation and the need for further research. And unfortunately, Dr. Whiteley took that and ran with it and said all dogs should be tested for renal dysplasia. These genes are liability genes for renal dysplasia. Enough so that my colleagues had to go ahead and do a research paper on their own to show that the genes that she is testing for are found in healthy dogs and in healthy wolves at high frequencies and don't cause renal dysplasia in those dogs. So all she has identified is a variant, and she's actually identified 6 different variants in the COX-1 gene, the COX-2 gene, that are not all related to each other. So it doesn't even make sense that different mutations in different areas and cause different functional things all cause one disease. All she found was something that varies that may or may not actually relate to the function of that gene. This genetic test should never be run, okay? It has nothing to do with renal dysplasia. If you have renal dysplasia and you test and it comes up positive, it makes no difference because it can also come up negative because these are randomly variable genes in the background of dogs. And that's why I bring it up, because my name is on that article as well, and it is not, but it does not prove anything, and it has also been shown that it has nothing to do with renal dysplasia. So unfortunately, you have no genetic test for renal dysplasia that should be, that can be run or should be run at this time. Canine multifocal retinopathy, or CMR, onset of 13 weeks of age. There's a localized area of detachment and degeneration. It can, in severe cases, it can progress to complete retinal detachment, and that would cause blindness, but in most cases it does not. But it still is something where we have a test for it, and we want to avoid it, so we do want to select against it, and this test is available across all genetic testing laboratories. So at the OFA, we've registered 109 dogs, 2/3 normal, 30% carriers, 8.3% affected. Paw print genetics, half normal, almost half carriers, 3.6% affected. Mars, 86% normal, 90% carrier, 2% affected. Embark, 82% normal, 17% carrier, 1% affected. Paw print genetics and Embark are going to be looking more at United States dogs because those are US companies. The Mars Embark is more the Genoscopa results, which is European testing. So it's telling you more about the European testing market. But we do see that we see some variation here. Paw prints probably doesn't have as many dogs as Mars or Embark, so maybe you have a little bit more skewed population, people that already know that there's carriers, closely related dogs, and they're testing for carrier to normal matings and getting a higher percentage, but these numbers are probably more realistic as to your carrier frequency for this disease. Again, it's not the worst possible disease to have in most cases, but it's something we have a valid genetic test for that should be utilized. And hopefully at some point when the whole problem of patents and the whole problem of publishing data, which should be done, but not being able to lose the funding for your laboratory and all those other outside and extraneous things, that eventually we'll have a panel where you can go to one place, send in a cheek swab on your Great Pyrenees, and come back with all the testable genes for many different disorders. Okay, let's talk about degenerative myelopathy. Okay, we're doing good here. So I'm an expert on degenerative myelopathy. I'm actually giving on Saturday at the virtual World Small Animal Veterinary Medical Association Congress, I'm giving the state-of-the-art lecture on degenerative myelopathy in the neurology section. And I've been studying this disease for decades, so I know a lot about it. It does not exist as a breed-associated disease in Great Pyrenees. So I put a call out, and I asked your club to put on your your Facebook lists and things, that anyone that thinks the dog had degenerative myelopathy to contact me. And 8 people contacted me, and I asked them to see if your veterinarians can get the records for your dog sent to me, and 7 out of those 8 did get the records to me, and none of those dogs had this specific disease of degenerative myelopathy. Many of them had severe spinal arthritic disease and lumbosacral disease that caused a lot of pain, and a lot of them are on non-steroidal anti-inflammatories. DM is not a painful disease. Okay, so that was caused by stricture or contracture of the bones on the spinal cord, causing a myelopathy or diminished neurological function. There are other types of myelopathies that can occur. Neuronal degeneration presents with hind-end issues as a myelopathy, but it's also a disease of the entire brain and peripheral nerves as well. But it presents just like a myelopathy with no pain associated with it. But it is not this disease. This is an old age dog related disease, average age of onset around 8 years of age, and progresses rapidly to paralysis and inability to walk at all. So even with a wheel cart, these dogs become paralyzed within 6 to 12 months, and then they're dead. And the small breeds like corgis, they can sometimes maintain them for a year or more, but literally they are paralyzed and invalids, and you're just feeding them and cleaning up after their messes and keeping them alive while they continue to deteriorate. But it is not. But it is a short-lived disease once that diagnosis is made. Any dog that survives, Great Pyrenees that still can stand after 6 months after its diagnosis or a year after the diagnosis, it's not degenerative myelopathy. That's not how this disease works. All breeds, and then what confuses the issue with this disease is the identification of the SOD1 liability gene for degenerative myelopathy. It is the most frequent mutation found across all dogs by Mars and Embark. Okay, 7 to 9% of all mixed breed and purebred dogs carry this gene. All right, but you don't see 7 to 9% of any dog coming down with degenerative myelopathy. In the affected breeds, it's less than 1%, or a little over 1% in some of the breeds that actually have the disease. But this disease is primarily a German Shepherd disease and a Boxer disease. And then you've got a handful of other breeds that have families that have the disease in very, very low percentages. You're talking 0.3 to 0.5% of the breed that actually can be affected. Bernese Mountain Dogs, Rhodesian Ridgebacks, Pembroke Welsh Corgis, Cardigan Welsh Corgis, Borzoi. And then otherwise there are a handful of other dogs that have been identified with this disease and confirmed with this disease as sporadic individual cases, which is exactly what occurs with Lou Gehrig's disease, or ALS, which this is the dog disease is a model of, where there are personal mutations that are not breed-related diseases that can cause the disease in an extremely rare situation in mixed breed dogs or other purebred dogs. And so 30 dogs have been identified, in other breeds at University of Missouri by pathology. It can only be identified and confirmed by a pathological examination of the spinal cord. But it can be ruled out based on the clinical signs, and that's what I did when looking at those records on those dogs, just based on the rate of progression, based on the clinical signs, that these dogs have myelopathies, their spinal cords are involved, but they don't have this particular disease, regardless of their test results. And most of the dogs that were sent to me were never tested for the SOD1 mutation, or they could have ruled out the disease just by knowing they didn't have 2 copies of that gene. And the reason why it's important for me to be teaching this to veterinarians and to owners is so that you can understand, because DM is a fatal disease. There's nothing you can do to stop this from killing your dog. But there are so many treatable diseases that can present like this, which is what's happening in your breed and many other breeds, that can be treated, or at least are not fatal So you don't need to put your dog to sleep, okay? Because you think it's going to rapidly die from this fatal disease. This disease doesn't occur in your breed. So you need to understand that. Genetic testing, 14.1%, 6% at risk, 6% based on the OFA testing, which is University of Missouri testing. Paw print genetics, 23.5% carriers, so a quarter of your breed being carriers. You don't need to select against this gene in your breed. It's got nothing to do with disease. Mars and EMBARK testing, almost 10% at risk based on Mars testing of over 1,500 Great Pyrenees dogs. You don't have 9% of your breed developing degenerative myelopathy as they get older. It just doesn't occur. And if you select against a third of your breed because they're carriers of the SOD1 mutation, it has nothing to do with disease in your breed, and you're just limiting your genetic diversity. You are decreasing your ability to select for and against other things by utilizing this test. You should never be testing for the DM gene. If you get test results from this gene, you need to ignore it because it's got nothing to do with disease in your dogs. Okay, just as an interesting sideline, and then we'll finish up by talking in the last half hour about breeding against genetic diseases and for the traits that you want to select for, and then I'll leave a little time for question and answer. Just as interesting, the greater than 1,500 dogs, Great Pyrenees tested by EMBARK, they have found other mutations that they didn't expect to find. They found 8% carriers of ameliogenesis imperfecta, or familial enamel hypoplasia. And this is a disease that's seen in, oh God, is it Malamutes or Huskies? It's in one of the Arctic sled breeds where their teeth, the enamel in their teeth don't develop properly and they got really ugly looking teeth. Anyone ever seen that in the Great Pyrenees? So anyway, they're the first people to report it. They reported it to me. They haven't published this information, but they shared all of their testing information, and because I know these guys and they want to do the right thing for you, even though they're telling you not to breed for homozygosity. It's not that their test results are inaccurate. It's an excellent company. It's just how they're interpreting it and what they're telling you to do with it. So in this regard, they're saying that they're finding 1% tested positive for Colli-I anomaly, 1% tested positive for urate stone formation, which is at high levels in Dalmatians that we know of. And ichthyosis is actually a genetic disease, a scaly skin disease in golden retrievers, and that they found a couple of copies of that. And you consider 1,500 dogs, so 1% is 15 dogs. So it wasn't just one dog it was found in. They found it in 15 Great Pyrenees. So something you need to look about, and when we start to really do full panel testing where all these things are included, is something you can pay attention to, because these are disease-related genes. Okay, so let's talk about breeding. And responsibility is important when we deal with breeding. So you look up the textbook definition or the dictionary definition of responsibility. It says duty, obligation, and burden. So what is their obligation for breeders to do genetic testing? What is the obligation of breeders to do what they can to prevent genetic disease in their dogs? And so that's a big question. Breeders are the custodians of their breeds and of your gene pools, especially as the National Parent Club. You breeders are the custodians of your breed, and what you do affects what happens to your breed in the future. Above all, do no harm. That's the Hippocratic Oath. That's what I take as a veterinarian. It's what physicians take. And as breeders, you're creating life, you're creating your dogs, and so it's something that you need to actually take into consideration as well. You don't want to create more disease. So you need to understand how to use genetic tests for the best interests of your breed. So what is the expectation of the general public? I've been using this slide for decades because at one point I Googled general public and this picture came up and I thought it was really funny. But in the age of COVID now, it's got completely different. But at any rate, what is the expectation of the general public? that quality control for genetic disease is being done. The people buying Great Pyrenees dogs, whether they're from you, whether they're from a background breeder, they think breeders have controlled, are controlling genetic disease, that it's automatically done. And we know it's not automatically done. We need to spend time doing it. We need to spend money doing it. And we need to make decisions based on health of our dogs. It's the ethical responsibility and obligation of all breeders to perform the available required pre-breeding genetic health tests on prospective breeding stock prior to any breeding. You don't test after you do the breeding, you test before the breeding, okay? This is one of our mottos at the OFA, health-tested parents for healthier puppies. If you're breeding healthy dogs, you have an expectation of healthier puppies, and that's what's important about OFA, the Canine Health Information Center, which is what CHIC stands for, Canine Health Information. All genetic disease cannot be prevented. However, we have the knowledge and the tools to improve the genetic health of puppies. So at least we make the effort with each breeding, with each generation, to improve the health of our dogs. So who is a responsible breeder? It is one that does genetic screening. If not, you need to find a different hobby or profession. Okay? If you're not going to do genetic screening for health, then you need to find something else to do that you can actually be good at, because you're not being good at being a Great Pyrenees breeder. And so that's an important thing, for me to say to you. If you're not going to do this, if you say, I just don't want to be bothered by that, then why don't you find something else to do? Because you're not helping your breed in any way if you're not going to screen for genetic disease. Many health tests can be performed during examination with your veterinarian or obtained inexpensively at local health screening clinics. So there are screening clinics that are being done at dog shows, or they're being put on screening days by different breed clubs, and where you can get everything done in one day. You can get your hips done, you can get your eyes done, you can get your hearts done, you can get your patellas done, you can do all that stuff. Many of the patellas you can do, your own vet can do. Some of these things require a specialist in order to do the screening. OFA does list health screening clinics on the website, but the best site for health screening clinic information is cavalierhealth.org. It's in the handout, but write it down. They do an amazing job. Every single health screening clinic in the United States and Canada is listed on their website. It lists where they're being done, what the dates are. If you roll over the heart part, it'll tell you which cardiologist is doing it, how much it costs, who to contact. Are they doing just auscultation? Are they doing echocardiograms? Same thing with the eyes. Any of these, it gives you the contact information so that you can register and get all your health testing done, one-stop shop in that way. They can even collect DNA for you to send in, but you do need to do your DNA tests as well. So managing genetic disease. So I'm not going to go over all the different modes of inheritance because I'm going to go over on time. So it's in your handout. I'm not going to talk about dominant disease or X-linked disease. They are far less frequent. I don't know of any specific dominance or X-links that affect peers at this time, but you can look at that. So I'm going to concentrate on recessives and on complexly inherited and polygenic, which includes any disease where the mode of inheritance is not known, because it's likely not going to be a simple Mendelian mode of inheritance. So recessive genes. This is a lot of different diseases. All of your testable diseases are autosomal recessive diseases, and many of your complexly inherited diseases have recessive liability genes that are included in them. And we know that because you can breed a normal to a normal and get an affected. And that means that recessive genes are being passed on, because if there were dominant genes, one of the normal parents would have been affected themselves. Okay, if you have a test for carriers, so we're talking about CMR, we're talking about dwarfism, we're talking about Neurology Generation, we're talking about Lanzmann's thrombocytopenia. So these are all autosomal recessive, completely penetrant genetic diseases. You want to breed your quality carriers to a genetically normal mate. Okay, so you want to breed your carriers. You have a genetic test. The whole purpose of a genetic test is to allow you to breed the dogs you want to breed. And you breed them to a normal and eventually replace the quality carrier parent with a quality, genetically normal offspring. Okay, 50% of the offspring are going to be normal, and hopefully a good quality offspring is going to be produced that you can replace your dog with that normal testing dog. You've lost that gene in one generation. If the best quality dog is a carrier, then you replace your carrier with another carrier, and in the next generation you try to lose that gene. You're never producing affected dogs, okay? And you're maintaining the quality of your breed. You do want to select against carriers for breeding. You don't want to put a whole bunch of carriers in breeding homes because the frequency of these genes is far less than 50%. And you're doing carrier normal matings, you're producing 50% carriers, and you don't want to increase the frequency of these genes. You want to select against carriers. If the best individual is a carrier, you're going to keep it, that's fine, but you don't want all the carriers going into breeder homes in that way. The proper use. Without genetic tests, our ability to identify carriers of recessive disease is zero. So we're guessing, okay? But the effect on the gene pool is very slim because we're really not doing a lot of selection. Once we have a genetic test, if everyone says, oh, my dog is a carrier, I can't breed a carrier, it's going to cause a significant effect on the genetic diversity of our breed. Some of these are carrier frequencies of yours are 25 or 30%. So you know, that's a significant portion of your gene pool. You don't want to just wholesale eliminate that because there's a lot of quality lines and quality dogs in there. But with a testable gene, you can breed your carriers and lose it in one generation. So this is a quote from Dr. Paula Henthorne, University of Pennsylvania, another excellent center of genetic disease research. If a breeder was planning on breeding an animal prior to receiving carrier test result, the proper response is to breed to a normal individual and eventually replace the parent with a quality, normal offspring. So what she says is, for recessive disease, a direct genetic test should not alter who gets bred, only who they get bred to. You want to breed your quality dogs, but if you have a testable gene and it's a carrier, that can't change your decision to breed that dog. That dog should be, you've already made the decision it's a quality dog, you've done your health conscious pre-breeding health testing, oop, it's a carrier of this gene. All it alters is that you can't breed it to another carrier. That's the only thing that it changes, not whether you breed that dog. So genetic registries, we have the OFA. We used to be called the Orthopedic Foundation for Animals. Some people still call us that. We are now OFA, the Canine Health Information Center, because it's so much more than just hip dysplasia. It is everything. And I'm going to just take a minute here and show you the website so you can understand all the tools that are available to you on the OFA website. Because it's been completely redone on the last time that you were at the website. We're using the Wi-Fi from the building here, so a little bit slow. Oh, screw nothing like that. Just give me mine. There it is. Okay, so here's the OFA website. So if you scroll down, what genetic health screens should my breed have? That's your CHIP requirements, right there. Breed statistics. You click that, you put in your breed, it shows you every single health test result on every single breed, Pyrenees, hips, eyes, elbows, all the stuff that I've summarized for you in one chart for your breed. If you are a breeder, how do you use the OFA as a breeder? If you are a veterinarian, what you should do about utilizing OFA as a veterinarian. If you are an owner looking to purchase a dog, how do you utilize and what questions you should ask the breeders about genetic testing. You've got here advanced search. So you can type in your dog's name and registration number, or you can search for dogs that you may want to breed to. And you can put in, I want a Great Pyrenees, and you can say, I want dogs with normal hips, I want dogs with certain test results or whatever, and it'll give you a list of dogs that fulfill those criteria. So it's a very powerful database there. I want to show you something down here, health surveys. These are breed health surveys for breeds where the parent club has asked the OFA to do an online health survey that anyone can fill out that has a Great Pyrenees, and it will give you the information about all the diseases, and it's an ongoing survey. And OFA can break it down. If you've got a survey going for 10 or 15 years, we can say first 5 years, next 5 years, next 5 years, you can see the trends and how things change. And it's all done for free to the breed club in a very valid online program. And as a breed club, you can standardize it to add things that you are particularly interested in. We want specific questions about osteosarcoma. What was the age? What was the death date? How quickly did it progress? We want specific questions about our testable diseases. So a very powerful tool, and something that I think that your breed and all breeds should utilize from the OFA in that regard. So a very powerful tool for you to use and utilize in evaluating dogs. Okay, the DNA repository. So OFA and CHIC, which is co-started by the Canadian Health Foundation with the OFA, we have developed a DNA repository so that DNA can be used by any researcher studying any disease in the future. And for any kind of genetics research to be done, you need a DNA data bank. You know, that's what has been built up for your dogs in Minnesota with the Dwarfism samples and now the Neurology Generation. But those samples can't be shared with other researchers. Legally, they can't be shared with other researchers. If you want to run a genetic test on a dog that's been dead and a new test comes up somewhere else, they can't send that sample somewhere else. You own the DNA there. If you sent it in on your dog, if a new genetic test comes up on a deceased dog and you want to know what your foundation dogs were, you ask the OFA to send a portion of DNA to the University of Minnesota, and you can have them tested, even though they're deceased, for dwarfism, for neuronal degeneration. If you have a straw of semen that you're no longer going to use, doesn't even matter if it's live or dead, the DNA's in there, you send that straw to the OFA, they will put it into the DNA repository. It's just as good as a blood sample. You've got 315 Great Pyrenees in there, but there's a lot more cheek swabs than blood samples. And cheek swabs are good for doing an individual test, but if you're actually researching to identify genes, you need a blood sample in there. So you guys need to build up a repository, a multi-generational repository, which takes year after year after year of drawing blood at specialties and at other club events and sending it into the OFA and building up that DNA repository. And if in the future you want osteosarcoma research to be done on your breed and not just on Scottish Deerhounds who have their own repository, then you can have osteosarcoma research done on your breed. It can't be done right now because you don't have the DNA samples or any other disease process. So I encourage you to build up that OFA DNA repository because it's something the breed club controls. You individually control your dog samples as well, and it will be helpful in the future. Lastly, the CHIC program, the standard of care in health conscious breeding. The beauty of the CHIC program, it's an open health database. It includes disorders and means of diagnoses determined by each national parent breed club. And the beauty is that animals receive a certification based on their completing the required genetic testing, regardless of the test results. This is not about normalcy, it's about health consciousness. It's about doing the genetic testing that needs to be done for your breed. And as more testable disorders emerge, every individual is likely to carry some deleterious gene. And once we get beyond the my dog is perfect and your dog is not, then we can at least start to deal with disease as a community of breeders that loves this breed and be able to improve the health of our dogs. No one wants to produce introduce a dog affected with something, and so when it does happen, it's not a reason to point fingers and to talk down, because the next dog that's affected with that thing is probably going to be your dog. And so really treat each other the way you would want to be treated. It's not something that anyone wants, unless they're completely ignoring health, in which case they got what they deserve. But it's what we need to do to improve our breeds. It's not about health normalcy, it's about health consciousness. So your health testing requirements, you have a funny kind of setup, whereas you have requirements. 2 requirements are hips and patellas, and then you need to do one of the electives, and you've got everything else on here: cardiac, thyroid, elbow, eyes, shoulders, and you've got DNA tests for GT and CMR, and I would add to the list your other genetic tests. But if you're going to do it this way, I would say at this point you need to say more than one. You maybe need to say 3 of these things, because are we really being health conscious by just picking and choosing which tests we're doing and which we're not doing? It does suggest all the things that can be done in your breed, where there are some low-level issues that are involved. But I think you need to think about reworking your chick requirements, because it's not completely screening for what you need, what each dog should be screened for before they are bred. And that's the purpose of the chick program and what the recommendations are. 993 peers have achieved chick certification, and I do a chick breed ratio, which tells me about the environments in the different breeds, how much genetic testing is going on. So I take the number of dogs that have achieved chick certification divided by the number of dogs, AKC dogs, that were bred during that time period. And your percentage is 11, it's not point, it's 11%. It's either 0.11 without the percent, or it's 11%. So 11% of your dogs that are bred have achieved chick certification, meaning hips, patellas, and one of those electives. Again, breaking down your breed to the middle third, you're at the top end of the middle third here. You're at 11%, which is exactly what the average for these are. But your averages reflect breed culture. Now, if you look at this here, look at these breeds. Belgian Sheepdog. 56% of Belgian Sheepdogs are chick certified that are AKC bred. Okay? You look at Bearded Collie. You look at English Setters, Swissies, Anatolian Shepherds, English Setters. Some of these breeds have a lot of genetic disease. English Setters have deafness, they've got hypothyroidism, so people are forced to test, but at least they're doing the testing. Others don't have as much disease, but they have a culture of testing and health consciousness. And that's what every breed needs, is to develop that culture. Pre-breeding health screening should become as universal as an equine pre-purchase exam. That's the culture. I don't breed before I do my health screening. It's a cultural choice. And so your breed needs to get up from 11%. It's the average, but you want to be better than the average in that regard. Bred with heart is a correlated health screening recommendation or requirement by the AKC, and because of that funky way that you set up your chick requirement, when you submitted that to AKC, all they saw were, well, these are the 2 required tests, and they don't even have any of the other tests. So anyone with a Great Pyrenees that goes to the AKC website thinks this is the only thing I need to test for. We know that's absolutely not true. So those are things that you need to think about in terms of reformulating your chick requirements and your bred with heart requirements. Okay, I wanted to show. So one other thing I want to show you on the OFA website, which shows you the power of this website, especially for complexly inherited disease. Okay, so I picked out a dog. Okay, this is, what's the kennel name? Yeah, that Mount Bellier, okay? Okay, so I picked this dog. That's your dog. Congratulations. Does anyone know this dog?
Yes.
Okay, whose dog is it? Congratulations. Okay, so I picked this dog for several reasons, okay? First off, First off, here's the dog's picture, okay? For a $10 donation through the OFA website with your credit card, that $10 goes to the Canine Health Foundation Donor Advised Fund for your breed. It can only be used for research as designated by your parent club through the health committee. And so you're donating $10 to peer research and you get your dog's picture on its webpage. This is Facebook for this is your dog's webpage. Actually, this is more like Tinder for your dogs, okay? So here you've got the dog with the information. Here we have all of the test results. Congenital cardiac, normal by a cardiologist. DNA has been submitted. It's a blood sample with a B instead of an S, okay, to the CHIC repository. Patella is normal by a practitioner. Eyes normal. Hips good. Elbows normal. Shoulders normal. CHIC qualified. Eyes normal again at 31 months of age, so you need to do your eyes annually if you're being used for breeding. What I say, a lot of the things that they say annually, if a dog's going to be bred every year, it should be done annually. If the dog's going to be bred once every 3 years, just get it done before you breed it the next time. You know, I mean, it'd be reasonable about it, but it's a pre-breeding health screening. Okay. What else we got? Neurology Generation, normal clear, multifocal retinopathy of carrier, degenerate myelopathy didn't need to be tested, thrombasthenia clear, chondral dysplasia normal. So this is telling you everything you need to know about that dog. And for those autosomal recessive diseases, that's all you need to know about the dog. But for the complexly inherited diseases, you actually need to know information about the family. So here are the two parents, and these are all the parents' health test results. Okay, you can click on their names if you want to see all the results. If they have a CHIC next to their name, they have CHIC qualified, so they've done their CHIC requirements. Here are the offspring of the dog with all of those results. Here is the full siblings to the dog. Here are the half sibs through the sire, half sibs through the dam, and the grandparents, and all of their results. This is all the depth and breadth of pedigree information that you need to know about controlling complexly inherited disease. You need to know what familial issues are going on with these diseases. And the easiest way to do that is through vertical pedigrees. So here's the vertical pedigree, and this can be done for hips, for elbows, for cardiac, and any of these things here, even for the DNA tests. Here's the dog, OFA good, 1 sibling good, 7 offspring that have been tested, 1 excellent, 3 good, 1 fair. That means there are other offspring that have test results that have not been released to the OFA, or have not been done. And so that's what you get there. His sire is good, has 1 sibling that's good, 10 offspring, 6 good, 2 excellent. You've got a dam that's excellent. Good, good, and excellent. Here's your grandparents. So here's your depth and breadth of pedigree information. But what's the issue that we're seeing here? And I would hope that there's all normals in there, but we're not seeing any abnormals, okay? Because for the OFA website to list abnormals, you have to check off for the release of abnormal results. And that's also a cultural thing that we need to develop so that we are going to honestly look at what diseases are present and not just by the omission of them say, oh, everything's normal and hunky-dory with our dog. So we need you to check off for the release of abnormal results on these dogs. I'm going to skip this because we're getting a little bit, we're at 11:30 right now. I'm going to finish within 5 minutes and we'll do some questions, but just to let you know for timing here. So here is the percentage of you that have checked off for release of hip results, of abnormal hip results when you submit your hip exams. And you know, you've been up in the figure, here's you had almost 40%. You dropped down into the 20s, you got back up into the 30s here. Last year you're at 31%. The average for all breeds is 23%. So you're actually doing better than the average for all breeds, but we need to do even more than that. So we really need to do that check off to release abnormal results. Every year I propose to the OFA that we switch the check off, so you now have to check off to hide the results on your dog, and I get pushback on it for political reasons or whatever, but certainly we need to encourage open reporting, And so I encourage you to do those checkoffs. It's the only way that you're going to recognize what's going on in your dogs. And if a dog's been bred and it has no hip or elbow results listed on the OFA website, you need to assume that they are affected. Because if they've been bred, why aren't normal results up there? They'd be normal if they pass, so I have to assume that they're affected and that if the results are not there. As long as we keep problems secret, we'll not be able to deal with them. Breeders need to be informed about the problems occurring in the offspring that they produce. The days of stigmatizing conscientious health testing breeders who have produced dogs affected or carrying hereditary disease is over. And I know that's a pie-in-the-sky statement, and I've been making that statement for a long time, but it's what should be going on. You know, to stigmatize genetic disease is not going to allow us to progress. We are a community, we are a family, that we love our breed, and we need to work together in that regard. So if you have direct genetic tests, all you need is a test of the genotype. You just need to test results to make breeding decisions, Neurology Generation, CMR, and so forth. If you only have phenotypic tests or no test for carriers, we need to know the results of affected of affected relatives to be able to understand the risk in our pedigrees. Without tests for carriers, breed to a higher risk individual to lower the individual's risk. Breed the higher risk individual to a low risk individual, replace the higher risk individual with low risk offspring, and repeat the process in the next generation. So you want to breed to normalcy as well as familial normacy, and that requires an open health database with the release of abnormal results. So with complex inherited disease, to finish up, we want to identify phenotypic traits tied to the underlying genes. Breadth of pedigree provides more information on the possible range of genes carried. Treat disorders as threshold traits where several genes must add up to cause that disease, and breed normal dogs from mostly normal litters. So for hip dysplasia, there's no OFA excellent gene. If there's a good or if there's a fair, why is it a fair? If there's laxity, maybe you need to get a pen hip to objectify that laxity. If there's shallow acetabula, maybe you need to breed to a dog that has deeper acetabula. So break down the disease into individual components that might more be directly inherited. We use depth of pedigree to say, oh, I've got 3 generations OFA, but it's breadth of pedigree that gives you more information about the genetics of your dog. So if you've got a dog from a litter where most of the litter is normal, then you can feel confident that dog's carrying a lot of normal genes. But if you have a normal dog who passed OFA, or it's normal for whatever complex inherited disease you're dealing with, and there's a lot of disease in the litter mates, then you really need to question what this normal dog is passing on and what it's going to produce. If we talk about threshold traits, the number of genes must cross a threshold. If we say 5 genes causes a genetic disease, if the average, theoretically, if the average of 2 dogs is at the threshold, then we can't be surprised to see affected dogs. The thing we need to remember about complex inherited disease is if 2 normal dogs are bred together and produce an affected, both parents had to contribute liability genes to that affected dog. So it wasn't just that stud dog that you bred to, okay? Both parents have to contribute liability genes if they're both normal and they produced an affected dog with complex inherited disease. And this is a chart of close to 500,000 dogs across all breeds that were OFA certified, where both parents also had OFA ratings. And we've taken the ratings of DAM from excellent to severe and SIRE from excellent to severe. We've numbered them, and we've added those numbers together and shown, you know, good to good is a 4, but fair to excellent is also a 4. And so all of the dogs that have similar combined parent scores, similar numbers, are colored here. And when we do statistics on it, they're all correlated together with each other. So you can see these numbers are very similar as you move down. And I want you, before we go to the next chart, I want you to look here. Good to good is over 217,000 dogs. That's almost half the database. But I need you to look here. Severe to moderately dysplastic is 48 dogs here and 62 dogs there. So there's not a lot of dogs in this category of 6 plus 7 of 12 or 13 there. And I want you to see that only because that's the only outlier. When you add up all the dogs with the combined parent scores and the amount of dysplasia it produces, hip dysplasia is being passed on as a completely additive disease when comparing the hip ratings of the dogs. So there is a genetic difference between OFA good and OFA fair, and you need to pay attention to that because it's a completely additive disease. Dogs need to have their radiographs done either under general anesthesia or deep sedation to the point of muscle relaxation. Using only physical restraint hides the true character of their hips. And as of January 1st, the OFA will be publishing your hip results with a designation for whether they were physically restrained or chemically restrained, because there is a difference between that. Physically restrained dogs underreport hip dysplasia. It may make you feel good, but it's not giving you accurate results. If you add how many normal grandparents there are, so adding depth of pedigree, even for excellence to excellence, no normal grandparents, 1 normal, 2 normal, 3 normal, 4 normal grandparents, it still decreases the frequency of hip dysplasia. So depth and breadth of pedigree information, as represented on OFA vertical pedigrees, helps you understand the liability for hip dysplasia and any other complexly inherited disease. So the last 2 slides. Breeders should use health screening to identify carriers or the risk of carrying disease liability genes, work to breed away from the defective genes, and prevent the reintroduction of those genes in future breedings. Each breeder must assess their own breeding stock and determine their own rate of progress. Maybe you're a carrier for CMR, maybe you're a carrier for dwarfism, maybe you've got fair hips and you need to get good or excellent hips. Replace carriers with normal testing offspring or decrease the frequency of carriers or carrier risk with each generation or liability. A healthy breeding program does not multiply carriers, does not limit the genetic diversity of the population, and is geared towards producing quality, genetically normal dogs. Lastly, how can we educate the public? We need to make them more informed consumers of dogs and puppies. If someone calls you and says, I'm looking for a Great Pyrenees, and you don't have a litter, and you think maybe someone else does, don't just give them their information and say goodbye. Spend a little time to talk to them about what questions they need to ask, about what things they need to look for to identify a health-conscious breeder, so that the public understands about health-conscious breeding. And the public understands they can look up the health tests on parents on the OFA website and make them more informed consumers and knowledgeable about genetic testing. And so I've gone over by 9 minutes. I apologize for that. If we have questions, I'm happy to take them, or if you want to come up afterwards. If you want to ask a question anonymously, you can type it in. If you need to go, I appreciate your staying here for the seminar, and enjoy your specialty, enjoy your dogs, and thank you very much. Any questions? Okay, thank you.
Can everybody who attended, could you put your name down on this piece of paper for me, please?